Good day, everyone. Welcome to our journey into the fascinating world of SQL Server query optimization. Today, we are diving deep into a critical aspect of SQL Server performance tuning, the often underestimated but incredibly powerful density values derived from the DBCC show underscore statistics command. As SQL enthusiasts and database professionals, we are always on a quest to make our queries faster, more efficient, and ultimately deliver better performance. And one of the keys to achieving that goal lies in understanding how SQL Server's query optimizer makes decisions. It's like deciphering the secret code that unlocks the performance potential on your database. Today, we are going to unlock a piece of that code by taking a closer look at the density values. Ever heard of them? Density values are like heartbeat of your data. They tell you how your data is distributed, how unique or repetitive it is, and they play a crucial role in the optimizer's decision making process. So imagine this. You are working with a database filled with information, perhaps an e-commerce site's product database with millions of records. You want to retrieve specific products efficiently, but how does SQL Server know which path to take? How does it determine whether to use an index, perform a full scan, or something in between? Well, that's where the density values comes into play. In this video, we'll show you how to harness the power of density values obtained from the DBCC show underscore statistics command to evaluate the query plans. We will explore whether these values can be your guiding light in determining whether you are getting a good, better, or bad query plan. Throughout our journey, we will dive into practical examples, real world scenarios, and expert tips to help you optimize your SQL queries like a pro. We want you to leave this video armed with the knowledge and tools to enhance your database's performance. So, buckle up. SQL enthusiast, whether you are a seasoned database administrator, a curious developer, or just someone who wants to understand the magic behind the scenes, you are in the right place. Let's embark on this SQL adventure together and uncover the secrets of SQL Server query optimization through the lens of density values. Stay tuned as we unravel the mysteries of SQL Server query optimization right here on this channel. If you are ready to master the art of making your queries perform at their best, hit that subscribe button and then let's get started. In this video, we will check for estimates that will basically be created by the SQL Server optimizer based on the density value that is found in the DBCC show statistics. I'll be using AdventureWorks TW database for this demo. I'm going to execute this query, which basically is going to list out all the rows from table 1, where the predicate is on column 4 and the value is 11 January 2024, 8:32 p.m. 6 seconds. So let's execute that query with the execution plan enabled. We are able to see that we are returning close to 13,000 rows for this particular query. Look at the execution plan, and we are able to see that we have an cluster index scan happening on object table 1. Let's look at the estimates or cluster index scan operator that is on table 1. What I'm able to see is like we are estimating close to 13,000 rows, and we are returning close to 13,000 rows. So it is very clear that we are estimating close to 13,000 rows. Let's look at from where we got this 13,000. So let's look at the list of statistics that is present in table 1. I'll be picking up the statistics that is present on column 4. In our case, this is the one. So let's execute this and then see from where we got the estimate value. So to check that again, I'm seeing like we are estimating 13,000 rows. So let's execute that and then go to the estimates here. What I'm able to see is like we have a predicate which is a direct hit on the histogram. So what I'm going to do is like I'm going to compare this value with this value, and will ensure like it is same. Yes, it is definitely same, and we got the estimate of 13,000 from the EQ rows because we have a direct hit on the histogram. Yep. Now what I will do is like I will use a local variable. I'm not going to give the values directly on the predicate. Instead, what I'm going to do is like I'm going to create a local variable at date t with a data type of date time, and then I will use that instead of the value directly. So let me execute it. And we are able to see that we are returning 13,000 rows. Now let's look at the cluster index scan on table 1 and see like how many rows we have estimated. So in this case, we are estimating close to 57.3 and returning close to 13,000 rows. So let's see from where we got this 57.3 rows. 57.3 rows is what we have got it here. 0.3. So now what I'm going to do is like, since we have used a local variable, the understanding is like the optimizer will be utilizing the density, all density value. So let's look at it further. So this is the statistics which is on column 4. If you want to check that, executed on column 4, we have this particular statistics here. So let me gain and then let me execute it. What I'm seeing is like the all density value is this. I will put the all density value here, and then what we'll do is like we will multiply the all density value with the number of rows that we have on the table 1. So let's execute that, and here we go. We are getting the same value as the estimate that we saw in the execution plan. So what we'll do is like we will execute these two queries side by side. Okay, we will put this one as well, the local variable, and then let's execute it side by side. And if you see here, we are estimating 57.30 rows, and all density value multiplied by the number of rows on table 1 is also same. So this is where the query optimizer derived the estimate for this particular query where we use the local variable. That's it for this video. Thanks for watching. Have a great day. Jai Hind.